We are now on section 2 of chapter 2. We will be talking about techniques of differentiation in that section. We've got lots of techniques. If you would know those techniques, it would be very easy to continue with this chapter, the upcoming chapters, most definitely, because this is a very that's the main subject that we are using for the other chapters that we have got. Okay, so I hope you would do very well in that section, in that chapter, so that you would do much more better in the upcoming sections and chapters that we have got. So the first rule that we have got is the constant rule. What is the constant rule? Let me write it here. I will not write the names of the rules that we have got, but in general, if I have got a function f of x that's equal to c, where c is any constant, okay, sorry, c is a constant. What do we mean by a constant? That means any number, number 2, number 3, negatives, positives, doesn't make a difference. What is the derivative of that function? F prime of x is equal to what? Is equal to 0. That is always true. Whenever you have got a function that is equal to a constant number, the derivative is equal to 0. Why is that? Let's sketch the graph of that function. Okay, a constant function, how does it behave? How do we sketch the graph of a constant function? It is simply a straight line passing through a point. That is a constant function. Okay, f of x, that's equal to c. Is that line? That's of course a straight line. It's a linear function that we have studied in the first chapter. What is the slope of that function? Does it rise? No, it's not rising. Does it fall? No, it's not falling. Since it is neither rising or falling, so it is 0. The derivative of this one, or the slope of that function, is equal to 0. Let me give you some examples about that. Examples not given in the course material, just a few examples for you. The first function, let me give you f of x that's equal to 3. 3, is it a constant number? Yes, it is a constant number. So the derivative of this function, if it is required from me to find it, that's simply equal to 0. Let me give you another function, f of x that's equal to, for example, minus 5. Minus 5, is it a constant number? Yes, it is a constant number, or we can say a constant function. So the derivative of this one is again equal to 0. Let me give another function, y is equal to, for example, root of 2. What is the derivative of that function? Since root of 2 is again a number, okay, it's not a function, be careful of that. So the derivative of that function is equal to 0. Let me write the other examples here. Y is equal to e. E is what? It's 2.17, right? So it is a number. So the derivative of that function is again equal to 0. If f of x is equal to, let me write pi. Okay, pi is equal to what? 3.14. 3.14 is a number, or it's any kind of other functions. It's a number, so it's a constant number. So the derivative of this one is again equal to 0. So whenever you see a constant, the derivative is equal to 0. That's easy. Let's move to the power rule. What is power rule? That's the second rule. If I have got f of x that's equal to x to the power of n, okay, where n is any real number, okay, that n is any real number. What does that mean, any real number? You're already familiar with real numbers. Real numbers consists of the natural numbers, rationals, irrationals, negative numbers, 0. In general, you can say it has got all kinds of sorts of numbers that we have got in general in mathematics. So real numbers include every number. What is the derivative of that function? F prime of x is equal to, we are bringing that n down right next to the x to the power of n minus 1. We are decreasing the power by 1. So if I have got, let's move to the examples, of course. Examples, these ones are not given in the course material, okay? F of x is equal to, for example, x to the power of 5, okay? 5 is a real number, it's a number, okay? So how do you take the derivative of that function? That's equal to the 5 comes in front like that did, like that ended it, okay? 5x to the power of what? We are decreasing the power by 1, so that's equal to 4. 5x to the power of 4. Of course, you are very familiar with this subject. Why? Because you've studied this once at high school. So it must be easy subjects for you. If we have got f of x that's equal to x to the power of 7, what is the derivative of that function? That's equal to 7 comes in front, x to the power of 7 minus 1. We are decreasing the power by 1, so that will be x to the power of 6. How about if you have got y that's equal to x to the power of minus 3? Y prime is equal to what? That will equal to minus 3x to the power of minus 3 minus 3 minus 1 is equal to what? Is equal to minus 4. We decreased the power by 1. You are not writing here minus 2. Why? Because minus 2 is 1 greater than minus 3. But minus 4 is decreased, but it is 3 decreased by 1. So let me give another example here. If you have got y that's equal to root of x. If I give you the function like that, first of all, what you have to do is to change that root of x into something in terms of powers. So that would be x to the power of 1 over 2. Okay? Why? Because you already have studied this one in college algebra, high school, that square root changed to 1 over 2. It's a power. So we are taking the derivative of that power. Y prime is equal to what? 1 over 2 x to the power of 1 over 2 minus 1. Decrease the power by 1. So that one is equal to 1 over 2 x to the power of half minus 1 is equal to minus half, minus 1 over 2. I will rearrange this one. Of course, if it just derivation is required from you, you can just simply leave it like that. But in the upcoming chapters, you would be studying applications of differentiation. In that applications of differentiation, you have to move the derivative into its simplest form. So it is better for you to make yourself get used to writing these functions in its simplest form. So how can I write this one in a simple form? That would be 1 over 2. If I have got negative power, what will happen to the concept that I have got? It will become upside down. So that would be 1 over x to the power of 1 over 2. 1 over 2 is what again? It's the square root of x. So that is the simplest form of x to the power of 1 over 2, or we can say root of x. That was the power rule. You can have much more examples if you want, but I think that would be enough. Let's move to another rule, that's constant multiple rule. What's a constant multiple rule? If I have got f of x that's multiplied to, that's equal to c of g of x, where that c is any function, that c is any number, any constant number, then the derivative of x, of f of x is equal to what? C multiplied to the derivative of g of x. What does that mean? That means if you have got, let's give examples, f of x that's equal to 7x to the power of 5. That 7 represents that c over there, and x to the power of 5 represents the g of x over there. So what's the derivative of that function? It says it's equal to c, okay, so I'm writing the 7 right here as it was, okay. Then I'm taking the derivative of the function that is given to me in here. So what's the derivative of x to the power of 5? It's equal to 5x to the power of 4. Simplifying this one, 7 multiplied to 5, that's 35, x to the power of 4. Let's give another example here. If y is equal to, for example, 3 multiplied to 1 over x squared. How do we deal with this one? First, we have to rearrange the function for the fact that we want, okay, that would be 3 to the power of x to the power of 3 multiplied to x to the power of minus 2. Now the derivative of this one is equal to what? 3 is written here, look, the constant, I'm writing it right there, and then the derivative of that x to the power of minus 2 is equal to what? Minus 2 x to the power of minus 3. Why minus 3? Because we are decreasing the power by 1. Minus 2 minus 1 is equal to minus 3. Okay, let's rearrange this one. That's equal to minus 6, okay, that to multiply together, and x to the power of 3 is equal to what? 1 over x to the power of 3. And that is for constant multiple rule. We are coming to sum and difference rule. Okay, the names are not important for you, just know the rules, that would be enough. What is sum and difference rule? If I have got a function with another function added together or subtracted together from each other, how do I take the derivative of this one? It's equal to what? F prime of x plus g prime of x. And if there was that negative sign there, we are writing negative instead of the positive sign. What does that mean? That means if I have got, for example, h of x, let me change it into an example. For example, I have got h of x is equal to 7x squared plus, say x. How do we take the derivative of h of x? H prime of x is equal to what? Consider this one as f of x and consider this one as g of x. We've got the positive sign between them. What is the derivative of 7x squared? That's equal to, the 2 comes into front, 12x. 2 multiplied to this one is equal to 14x. Okay, that one is 14x. We have got the plus sign. Why? Because it says if I take the derivative of that bit, that means I'm taking the derivative of the first one plus the derivative of the second one. We already took the derivative of the first one, that's equal to 14x. We have got the plus sign. What's the derivative of x? That's equal to 1. Okay, we can take the derivative of each bit separately. It's different from that constant multiple rule. Okay, let me give an example with this one. Okay, f of x, that's equal to 7 plus x to the power of 5. What is the difference between this example and that example? Here, in that example, the 7 is multiplied to this x to the power of 5. That's why we were writing it down again. Look, here we are writing it down and then taking the derivative of that bit. But here, if you look at that, f of x, it is given into 2 terms. Here, it's only one term, one piece of function is here, okay? That is only one piece, one term. But here 7 plus x to the power of 5, that one is 2 terms. Okay, 2 terms. Each one alone is a function, but this one together is a function. Okay, so what is the derivative of this one? F prime of x, it says we can take the derivative of this one alone plus the derivative of this one is 5x to the power of 4. So the result of that is equal to 5x to the power of 4. Of course, you would do the same procedure. If this plus is changed into a negative, you will put a negative here. If this one is changed into a negative, the negative in here will change the problem. Okay, we are given an example. Of course, lots of examples. We have got example 2.21. 221. It's required from you to find the derivative of minus 7 over root of x. How do we take the derivative of this one? First of all, we have to change that root of x into a power function. So that will equal to minus 7 x to the power of 1 over 2. And when I'm taking it up, it will be x to the power of minus 1 over 2. Okay, here this one is x to the power of 1 over 2. When I am taking it to the numerator, a minus will present there. Okay, let's take the derivative of this one. F prime of x is equal to what? Is equal to minus 7. What is the derivative of that bit? Let me try to find this one. that will come in front, that power, x to the power of minus 1 over 2 minus 1. Why did I do this one? Because we are decreasing, look, the power comes in front and we are decreasing the power by 1. So that one is equal to what? Minus multiplied to minus is equal to positive 7 over 2 x to the power of minus 1 over 2 minus 1. If you remember, you're equalizing the denominators. Let me do it here for you. So that is 1 over 1. That would be minus 1 over 2 minus 2 over 2. Equalizing those denominators together. We're multiplying this bit by 2. So that will be minus 3 over 2. So that one is minus 3 over 2. Simplifying this fact more, that would be 1 over x to the power of 3 over 2. Why did I do like that? Because that negative turns it down. Okay, so that one is 7 over 2 multiplied to 1 over x to the power of 3 under the square root. You know, this one represents the power and that one represents the root. So that is the derivative of that example given to us. Another example is here. We've got example 2, 2, 2. Or let me move from example 2.2.2. I will move to example 2.2.3. Okay, that one is more logical and of course the same way of solving. Differentiate the polynomial, it says. Okay, the polynomial that's given to us, p of x, that's equal to 5x to the power of 3, minus 4x squared plus 12x minus 8. Polynomial is given to us, it's required from us to simply differentiate that polynomial that is given. So, p prime of x is equal to what? That 3 comes in front, multiplied with 5, that would be 15x squared. 2 comes in front, to multiply to 4, that's equal to minus 8x plus 12x, the derivative of it is equal to 12 and the derivative of this one is equal to 0. Of course, taking the 0 away from the equation, you will get 15x squared minus 8x plus 12 as a solution or as the differentiation part of that example. We have got another example here. It's a word problem. Of course, you're familiar with how to solve word problems from last chapter. We have got, it is estimated that x months from now, the population of a community will be p of x, that's equal to x squared plus 20x plus 8,000. At what rate will the population change after 15 months from now? By how much will the population actually change during the 16th month? So we said, in general, first we are giving a quick review, quick reading of the example that we have got, and then we are starting to analyze it. Let's analyze it. It is estimated that x months, so what does x represent? X is representing the number of the months. Okay, it's not years, not time period or anything, it's the number of the months that's given to us. The population of a community will be p of x, that's equal to that function. So what is the population function? Population is equal to x squared plus 20x plus 8,000. Why is it x here? Because the population changes depending on the months. Of course, after this month, the population will change to that much. After 2 months, the population will change by that much, and so on. That's why the population function is given in terms of x. Why x? Because x is the number of months that we have got here. The first requirement that we have got, it says, at what rate will the population change? What is required here? Rate of change. If you remember from the first section, 2.1, I said there are 3 notions in that section you have to know that are related to each other and give the same meaning. Rate of change, slope, and derivative. So if it is required for me to find the slope, you're finding the derivative. If it's required for me to find the rate of change, you're again finding the derivative of that function. So here, the rate of change of population is required from you after 15 months from now. So x is equal to what? X is equal to 15. X is the number of months. So x is equal to 15. What is required from you? Rate of change is required from you. Rate of change is what? It is the derivative of the function. So the derivative of the function is required from you, and you're putting 15 into the function that we have got. So rate of change, I will write it here, okay? Rate of change is equal to the derivative of the function. What is the derivative of this one? That's equal to 2x plus 20, okay? 2x plus 20 plus 0. That 0 is vanished, so it is only 2x plus 20. Rate of change is required after how many months? After 15 months. So we are finding rate of change. Rate of change is the derivative after 15 months. So that would be 2 multiplied to 15 plus 20. That would be 50. So in general, okay, that's per month. In general, the rate of change of the population increasing is 50 per month. So 50 persons are, for example, born in that community. That is the average, okay? Of course, when we are talking about the rate of change, it's the average of that thing that we are doing. Let's move to the second requirement. It says, by how much will the population actually change during the 16th month? So we said that rate of change is like every month the average of people increased in that community is 50. But here it says, by how much will the population actually change during the 16th month? So 16 is what? 16, let me write it here. X is equal to 16. Here the number of months is 16th. But what else is given to me? During the 16th month. And actual change is required from me, not the rate of change. Rate of change is the derivative. Actual change, that means in the 16th month, the population has increased by what number? Okay, we are not finding rate of change here. We are using the actual change. What's the actual? That means the actual population. Okay, actual change. Okay, actual change is the number of actual population. Here we said rate of change is the derivative of the population, but actual change is the actual population. It's required from you to find the actual number of population increase or decrease during that month. So during the 16 months, look, there is the difference between after 16 months and during 16 months. During 16 months, that means it is only required from you to find the number of people changed in the 16th month, not after 16 months, because if it is after 16 months, that means you're also calculating month 1, 2, 3, 4 till 16. But when it's required from you to find the actual population in 16 months, so you're only calculating 16 months. How do you find this one? We are simply putting 16 into that function minus 15, okay? If you remember from from chapter 1, we also had an example like this one. I think it was the first word problem that we solved. So that one is equal to what? That one is equal to 16 squared plus 20 multiplied to 16 plus 8,000, okay? All minus 15 squared plus 20 multiplied to 15 plus 8,000. And of course, doing that calculation, you will get the population is equal to 51 people. يعني فرق لبيني أما وأوجيا أو بشوية كي قشتيتو باسي دكي ضلي بمعدل لهرمانجيك بنجا كسلو كوميونيتي زيادة أكاد بس ليرا كداواي actual population دكا مانجي شانزهم يعني تو تنها سير دكي بزاني لمانجي شانزهم تەنها مانگی 16 population چەند کەس زیادی کردیە نەک rate of changeەکەی ڕێتەکەی نادۆزیتەوە in general هەر مانگە و چەند کەس زیای کردیە بەس تەنها لە مانگی 16 چەند کەس زیادی کردیە 51 کەس زیابووە لەو community. Okay, so that's the word problem that we had. We have got of course other examples regarding to rate of change, and we will have new notions in that section, which is rectilinear motion. Okay, so when we are talking about rectilinear motion, it's also an application of derivatives. Okay, how derivatives are used while talking about rectilinear motion. What is a rectilinear motion? You may have studied, you have definitely studied this one in physics. If you have got an object, okay, for example, I have got this one. If that object is dropped, look, I'm dropping it without giving any velocity, any initial velocity, that's called dropping. Just the gravitational force is dropping it down. If it is thrown, it's just, I'm giving little bit velocity to that object and I'm throwing it. And if it is fired, firing is what? You're giving a lot of velocity in a very small period of time and you're firing it. When you're firing it, it's going very fast. Okay, so if an object is dropped, okay, let me write it here. If it is dropped, okay, thrown and fired, we have got rectilinear motion. Okay, when we are talking about rectilinear motion, we have got three things to consider. We have got position of an object. Of course, you have got a position for that object when you're throwing it, when you're dropping it, when you're firing it. You have got a position for that one. So in general, position will be written as s of t. Then you have got velocity. What is velocity? Velocity is the rate of change of position at a given time. So look what I said, velocity is the rate of change of position. Since it is rate of change of position, so v of t is equal to the derivative of the position. Why? Because velocity is the rate of change of position. Course, with respect to time that is given to us. Since it's rate of change, that means I'm taking the derivative of s of t. Acceleration is what? Velocity يعني خيراي. Acceleration يعني تاودان. Acceleration is equal to what? Is equal to the derivative of the velocity. Why is it equal to the derivative of the velocity? Because acceleration is again the rate of change. Look again, rate of change. When we talk about rate of change, that means the derivative of velocity with respect to time. So velocity is rate of change of position, so we are taking the derivative of the position and we will get velocity. And acceleration, if it is required from you, are taking the derivative of the velocity and will give you the acceleration of that function. Of course, if the velocity is a positive number, that means it is advancing, the object is moving, okay? And if the velocity is less than 0, that means the object is nearly trying to stop, okay? Having no motion, or if it is going the opposite direction. And you know also accelerating and decelerating, if acceleration is greater than 0 and less than 0. We have got, in general, when we are talking about positions, we have got the motion of a projectile, okay? When we are talking about the motion of a projectile, this whole notion I have described it for you, because we need these ones for the motion of projectile, of a projectile. So what is projectile? If as I told you, it is an object dropped, thrown, or fired. And when we are talking about this dropping, throwing, and firing, we will need those notions of rectilinear motion. We have got an example here, although it is related to physics, nothing to do with business math, but this is an application of the derivative. How do we use derivatives while we are solving equations? And it is also a word problem. That's why this example is given to you here. When we are talking about the motion of a projectile, in general, the height, let me write this one here. I will do the example later on. The height of a projectile, we will need it. The height of the object will be given to you as h of t. Okay, height of the object at time t is equal to minus 1 over 2 g t squared plus v naught of t, v naught multiplied to t plus h naught. What are those notions? G is the gravitational force. What's gravitational force? Well, in general, gravitational force you have studied, it's a constant number, and that's always equal to 32 feet per second squared. Okay, so that's a constant number. You have to know this one, or in general it's given in the book in section 2. V naught is the initial velocity that's given to the object. What are the kinds of velocity that we have got? Either the object is dropped. If it is dropped, initial velocity is equal to 0 because you're giving no velocity at all to the object. You're just dropping it without giving any velocity, so initial velocity would be 0. If it is thrown or fired, initial velocity will definitely change according to the example that would be given to you. H naught is what? It is the initial height. Why do we need initial height? Because maybe the object that's thrown, if the object you're throwing, maybe you're on a building, maybe you're on the ground, maybe you're on a table, you're throwing the object that you have got. So the table that you are on will be the initial height. The building that you are on and throwing the object or firing or dropping the object will be the initial height of the object that we have got. Okay, so that is what we have got, rectilinear motion and the motion of the projectile. I will explain the example that we have got about rectilinear motion in a separate recording because it takes some time.